All right, real quick, talk about friction just a little bit. A reminder that friction is a force that opposes motion. Okay, so whatever direction the object's moving, friction will always act to slow it down. So it's always going to act against it. Um, Other thing we have to know is that there are really two types of friction that we're going to talk about in here. We've got something called kinetic friction. And I like to associate kinetic friction with things that are moving or sliding. Because the object has to be in motion in order to have kinetic friction. The word kinetic meaning motion in general. We have our kinematic equations, things like that. It's always talking about objects that are moving. So you can consider kinetic friction to only be applicable when the object is sliding. Okay, and there's a formula for it. And sometimes you'll see like force of friction of F of K, or you might also see this, just force of friction. But either way, it would be equal to mu of K times the normal force. Now, mu is something referred to as the coefficient of friction, or in this case, the coefficient of kinetic friction. Okay. Kinetic friction, of course, is when it's moving. But if you've ever tried to move something, you've probably noticed that it's a little bit harder to get it started than to keep it moving. So there's another type of friction called static friction. Now we talked about static forces being forces where things were all canceling out or balanced or something like that. Static friction can be described as the force required to begin or break the original friction force. Force required to begin motion is what I'm going to use. So you might see this as F of S, or again, you might just see it as F of R. Thing a little different about this is that particular friction is either less than or equal to mu of S times F of N. And the reason that it's a less than or equal to is that the force of friction is greatest at the very beginning, and then it gets less after you break the coefficient of static friction. If we were to graph it, let me see here. I'm going to shift this up here a bit. Okay, if we were to graph what this would look like, okay, or if we had an applied force and then the friction force over here. Okay. As you apply a force, the force of friction would get greater and greater and greater and greater and greater, and then at some point it's going to start to move, and it drops down and then becomes fairly constant. This constant section here would be where kinetic friction occurs, and this peak is where static friction occurs. Okay. And again, I think it's fairly common sense to get that because, again, I always feel like it's much harder to get something going. If you ever watch any of those strongman competitions where they try to pull like a train or a semi or something like that, you notice that they really, really strain at the very beginning of it, but then once it starts rolling, it's actually a lot easier to keep it moving. Okay, so that's kind of the basics behind friction. Okay. So, that's my little blurb on friction.